Hello and welcome to week 10 in algebra. We are going to start up with the warm-up, so make sure you've got your math notebook out and you're ready to take good notes. The warm-up problem I'm going to do, I pulled a problem after looking at your homework from last week. And when I was grading the Unit 2 Session 6 assignment on graphing functions when given a domain, I saw quite a few of you were finding the domain for the entire line if we graphed it. But I want to make sure that we understand finding the graphic or finding the domain when we're given a specific domain versus when we find the domain of the entire linear equation. So what do I mean? So let's take a look at this warm-up. It says graph for the domain when x equals 1, when x equals 3, when x equals 5, and when x equals 7. So we're given specific x values. And remember, our x values represent our domain. So when we are graphing for a specific domain, we're only going to be graphing points because we're only going to be graphing each x value and the corresponding y value. So we're not going to be drawing a line through the points because we only want to graph for these specific x values and then their corresponding y values. So how do we know what the corresponding y values are? Well, look further down. It says graph for the domain when x equals 1, 3, 5, and 7. And then here is our function that we're going to use to plug in our x values and find our corresponding y values. So right now we're given our x values and we want to find our corresponding y values. Well, look where y is located, right smack kind of in the middle here. We've got a 2x plus y equals -1. So if we plug in x equals 1 for x, it's going to be kind of hard to figure out what our y value is with the way the equation is currently set up. So our first step in our warm-up is that we want to solve for y. We want to get y all alone. So that way, when we plug in our x value, it's going to be really quick for us to see what the corresponding y value is. So we're going to solve for y. We've got 2x plus y equals -1. So we want to work on getting y all alone. So in order to solve for y, we need to move this 2x to the other side of the equation. And we can do that by subtracting 2x. X is being added. There's a plus sign. There's not a negative sign. So if there's not a negative sign, we know that that 2x is positive. It's being added. So we're going to subtract 2x. We're going to do the opposite of adding. We're going to subtract 2x from both sides. Then we get y equals -1 minus 2x. Or you can have -2x minus 1. It doesn't matter which order. The important part is we solve for y. So now that we've solved for y, we can plug in the values of x to get our points that we're going to graph. So let's go ahead and do that. I'm going to move up here. So our equation, remember, is y equals -1 minus 2x. So let's plug in x equals 1. So when x equals 1, that means whenever I see an x, I'm going to plug in 1. And I'm going to do the math. Y is going to equal -1. -2 times 1 is -2. So -1 minus 2 is -3. So when x equals 1, y will equal -3. And we can write that as a coordinate, 1, -3. So we're going to keep on going here. I'm going to do a different color to do my when x equals 3. So now we're going to do x equals 3, and I'm going to plug that into y equals -1 minus 2 times 3. And what do we get? I'm going to just do some space saving here. -1 negative 2 minus 3 is negative 6, so we're really taking negative 1 minus 6, and I get negative 7. So my next point will be at, what do we have? 3, negative 7. When x is 3, y was negative 7. So my point will be 3, negative 7. Next, let's change colors again. Let's do x equals 5. Y equals negative 1 minus 2 instead of an x. We're going to have 5. We're getting really small numbers here. So we would have negative 1 minus 10, which gives us negative 11. So my next point that I'm going to plot would be at 5, negative 11. And then our last one we're going to do is 7. Green. When x equals 7, what does y equal? Well, y equals negative 1 minus 2x. Plug in that 7 for x. So now let's go through and simplify. Negative 1 minus negative 2 times 7 is negative 14. So negative 1 minus 14 is negative 15. So when x is 7, our corresponding y value is negative 15. And then we're going to plot all these points. Hold on a second here. All right, I just moved everything up here so that I can graph. So remember, here's our original equation when we solve for y. There's our y. So when x equals 1, we got negative 3. When y equals 3, we got negative 7, and so forth. So here's all of our points. These are the only things we're going to graph. We're going to have a bunch of points. We're not going to draw in a line because we're only graphing for this specific domain. We're only graphing for a specific domain right here. So we're not going to draw in a line. We're not going to intersect our points. So we would draw in a coordinate plane. And actually, I'm going to move this because we've got a lot of negative numbers. So I'm going to move my horizontal axis up because we've got a whole lot of negative numbers. And let's put in a scale. I'm going to do a scale of 2. So when we go, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. We don't actually have any x's in the negatives, but we have a lot of negative values for our y's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ignore what I said about a scale of 2. Ignore that. So let's plot our points now. So 1, negative 3 means go to the right 1 and down 3. There's that 1, negative 3. Then we're going to do 3, negative 7. So we go to the right 3 and down 7. So right about there. Then we're going to do 5, negative 11. Plot our next point, 1, 2, 3, 4, 5, negative 11, about there. And then our last point is at 7, negative 15. And then we're going to stop. We're not going to connect any points. 1, 2, 3, 4, 5, 6, 7, and down 15 down at the end here. Oops. 7. Right there. And then we're done. We're not going to connect our points. We're going to leave it as is. It's going to be points because we're graphing for a specific domain. If it just said graph and it didn't have this part here, if it just said graph this, then we would connect our points. But it does not tell us to, or I'm sorry, it tells us to only graph for that specific domain, and that's why we only have points. So I just wanted to make sure everybody understood that, and let's move on now. What are we doing this week? So this week we're going to look at graphing linear equations in standard form. We're going to learn what standard form is. We're going to look at rate of change and slope, and then we're going to look at writing equations in point-slope form. So we got 2 different types of form we're looking at this week. Standard form, point-slope form, and then we're going to look at rate of change. So let's dive right in. All right, so let's review slope. It's probably been a while since everybody's thought about slope in math, right? So remember, slope tells us how quickly or slowly our line is rising or falling. So slope tells us how quickly we're increasing or how quickly we're decreasing. And we can find the slope between any 2 points on a graph. We can find the slope between any 2 points on a graph. We just need to remember the slope formula. So if you forget slope, go ahead and click pause and do a quick web search and type in formula to find slope. Otherwise, if you remember it, go ahead right now and write down the formula to find slope when you're passing through 2 points. All right, so the formula to find slope when you've got 2 points, remember slope is rise over run. So then the formula, remember rise tells us up or down. So to find the slope, the formula that we use is we subtract the difference between our y coordinates. And run tells us left or right. So to find the run, when we do the slope formula, we subtract our 2 x coordinates. So the reason I put rise over run is that if you know that slope is rise over run, it'll help you remember how to find the slope. Rise, again, is up or down. So to find the amount we're going up or down, we're going to subtract our y coordinates. And then to find the run, we're going to subtract our x coordinates. So the formula you need for slope is right here. So slope is going to equal, you're going to subtract your y coordinates and then put that over when you subtract your x coordinates. So when you've got 2 points, like here, and this is what we want to find the slope between, is the slope between point -4,6 and point -2,1. So this is our first point, so we would call this x1 and y1. This is our second point, so we call it x2, our second x coordinate, and our second y coordinate. So now, go ahead and try to find the slope between those 2 points. So this is review, so go ahead and try this on your own. See how much you remember of it. Find the slope between those 2 points using the slope formula we just reviewed. All right. So go ahead and click pause and do that. And then when you're ready to check your work with mine, go ahead and click play. Okay, so to find the slope, we're going to subtract our y coordinates first. So we're going to have 1 minus 6. And then we're going to subtract, I'm going to do this in a different color, just highlight them, your 2. We're going to subtract our x coordinates on the denominator. So we would have -2 minus -4. Notice there's a double negative because we're subtracting our coordinates, and one of our coordinates was a negative number. So we have a double negative. That's okay. 1 minus 6 gives us -5 for our numerator. And then we've got a double negative, so it's going to become plus. So -2 plus 4 is 2. So the slope between these 2 points is -5 over 2. What does that slope tell us? How are we moving from point to point? We would be going down 5 and to the right, oops, yeah, to the right 2. That was just really sloppy. So again, the number on top tells us up or down. Since it's negative, we go down 5. The number on the bottom tells us left or right. Since it's positive, we're going right 2. So that's how we find the slope when we're given 2 coordinates. We can also find the slope from a graph. So do you remember how to do that? So should be review. So go ahead and look at this line and tell me what the slope is of this line. And remember, just find 2 points and find the rise and run between those 2 points. Go ahead and click pause and try this on your own. When you're ready to check your work with mine, go ahead and click play. All right, so when I find slope from a graph, I like to find specific coordinates, like where it sits on a corner, because this has definite coordinates. And where is another point? Right there. And how do we go from this point to this point? Looks like we're going up 2. So we're going up 2, that's our rise, and then to the right 1, 2, 3. So we're going 3 right. So the slope is going to be rise over run. So the 2 goes on the numerator and the 3 on the denominator. So the rise is positive, or the slope is positive, because we're increasing as we go from left to right. And specifically, we're going up 2 and to the right 3, giving us a slope of 2/3. I'm going to go on the next slide, so if you need more time, go ahead and click pause. All right, so let's review the slope of vertical and horizontal lines. So how do we, what is the slope of vertical lines? So let's review that. Let's find the slope of this line. Let's plug it into our slope formula. So remember, it's change of y over our change of x coordinates. So let's choose 2 coordinates. Let's do this one and plug it in. So this coordinate here is 1, 2, 3, 1. And then this other coordinate down here is 3, 0. So let's plug those in. So change of our y coordinates 1 minus 0. And then change of our x coordinates 3 minus 3. So we get 1 over 0. Uh-oh. Type in a calculator 1 divided by 0, and what do you get? You should get undivided. You can never divide, you can never have a 0 on your denominator. So the slope of vertical lines is always going to be undefined. Undefined slope. It's always going to be undefined when you've got vertical lines. So write that in your math notebook right now. What about for horizontal lines? Well, let's do a quick, we've got a horizontal line up here. Let's do a quick calculation of the slope of this line. So let's use these 2 points right here. They're both on our -5, 5 and 5, 5. They're on our horizontal line. So remember, slope, we subtract our y coordinates. So 5 minus 5, and then we've got 5 minus -5. That becomes 5 plus 5. We had a double negative in there. 5 minus that other 5. So we get 5 minus 5. Now we get our 0 on our numerator. So what is 0 divided by any number? It's always 0. So the slope of horizontal lines will always be 0. So just a review, but put those in your math notebook right now. So vertical lines will always have undefined slope, and horizontal lines will always have a slope of 0. So put that in your notes right now. And we're going to keep going. Rate of change, rate of change. So look at this line right here. Rate of change is just a fancy way of saying slope. In rate of change, another way to look at it, not only is it represented by the slope of a line, but it describes how one quantity changes in relation to another quantity. And those quantities are going to be the difference between the x-axis, what it's labeled as, and the y-axis. So let's review that again. Rate of change describes how one quantity changes in relation to another quantity. So let's take a look at this graph here. It is representing the speed of a sloth. So speed, remember, we compare the distance something travels to time. That's what speed is, comparing distance to time, something travels. So rate of change, we just said describes how one quantity changes in relation to another quantity. So looking at this graph, the rate of change is comparing the time and distance that a speed travels. And again, it's also really just the slope of a line. Rate of change is represented by the slope of a line. So if we want to find the rate of change of this graph below, we want to find the slope of the line. That's all we're going to do is find the slope of the line. So the rate of change is going to be equal to the change in y over the change of x. So again, really just finding the slope of this line. So we just did that on the previous slide, didn't we? So to find the slope, we want to find two places, like right here. It's on the corner of one of my my boxes and right here, so that we can easily see the rise and run. So we're going up 3 units and to the right 1. So the rate of change is going to be equal to 3 over 1. So let's, it's 3 over 1. And what does that mean? Remember, rate of change compares how one quantity changes in relation to another. So what does that vertical change represent? The distance. So for every 3 feet, the sloth is, for every minute, the sloth travels 3 feet. Or the sloth will travel 3 feet in 1 minute. And that is our rate of change. That is our rate of change. So again, it's just a fancy way of dealing with slope. Just a fancy way of dealing with slope. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. Linear equations. So we know linear equations are equations that when we graph them, we get a straight line. And we can write linear equations in several forms. So you're probably most familiar with slope-intercept form. So let's review all the different forms. Slope-intercept form, y equals mx plus b, where m represents the slope and y represents where the line will cross the y-axis. That represents b. B represents the y-intercept. There's also standard form. There's also a standard form where it's written as ax, where a is represented by a number like 5x, plus by equals c. So really, for standard form, all of your variables will be on one side of the equation and all your constant terms will be on the other side. That's standard form. And then there's point slope form, where we write it as y minus y1 equals m times x minus x1, where x1 and y1 are a point. So we would grab a point, plug it in for the y1 and the x1, and then m represents the slope. And we're going to look at these more in depth this week. We're going to look at standard form, slope-intercept form, and point slope form more in depth this week. So let's look at putting a line into each form, each of those forms. Slope-intercept form, point slope form, and standard form. So we can take the same line, if we have a line on a graph, we can take that same line and we can express it into each of those 3 forms. So that's what we're going to do, is we're going to take a line that passes through point M that has coordinates 2, 2, and point N, which has coordinates -4, 1, and we're going to put that line into those 3 different forms. So in order to do that, the first thing we want to do is identify the slope, because in each of our forms, it helps when we know the slope. So let's go ahead and find the slope. So go ahead and click pause and find the slope between these 2 points. It's good practice. So click pause and find the slope on your own. All right, so slope, remember we're finding the difference between our y coordinates over the difference between our x coordinates. And when we do that, we're going to have -1 minus 2 over -4 minus 2. Do the math. -1 minus 2 is -3. -4 minus 2 is -6. We've got a negative divided by negative, so we know that's the same as a positive 3/6, and we can reduce that to 1/2. So the slope of the line that goes through those 2 points is going to be 1/2. So let's start with the slope-intercept form. So we know the slope-intercept form is represented by y equals mx plus b, and we already know the slope, but we don't know the y-intercept. We don't know the y-intercept. But we have enough information that we can plug into the equation to find the y-intercept. So what I'm going to do is I'm going to choose one of my points. I'm going to choose the fact that I know m equals, or m is represented by 2, 2. I'm going to plug, well, I'm not even going to put an m. That might be confusing for slope. So I know one of my points is 2, 2. So I'm going to plug it into this equation. So instead of putting in y, I'm going to plug in 2, because y is 2, equals, I know my slope is 1/2. I know my x is 2. And I'm trying to find the y-intercept. I'm trying to find b, what b represents. So now I'm just going to do the math and solve for b. So I'm going to simplify 1/2 times 2, I know is 2 over 2, which is 1. So 1/2 times 2 is 1, plus b. And to solve for b, I'm going to subtract 1 from both sides, and I get b equals 1. So now that I know b equals 1, I know my slope is 1/2. I can plug all that information in to get slope-intercept form now. So slope-intercept form, I only substitute numbers in for m and b. So y equals 1/2 x plus 1. There's my slope-intercept form. So again, for slope-intercept form, I only substitute in numbers for m and b, our slope and our y-intercept. Point slope form. This one I think is kind of easier to do. We're only going to substitute numbers in for y1, m, and x1. So let's choose one of our points. Let's go ahead and use m or n again. M, that point has 2, 2. So we know one of our points is 2, 2, and we know our slope is equal to 1/2. So let's plug that in to point slope form. So y minus, my y coordinate is 2, equals m, I substituted my slope, x minus x1, it happens to be 2 as well. And I'm done. That's our point slope form right there. Let me go ahead and circle that. And then last but not least, standard form. And again, really all we're doing is we're taking our slope-intercept form and get all of our x's and y's on one side and a constant term on the other. So when I like to go from slope, if we have slope-intercept form, y equals 1/2 x plus 1, all I do is move this x term to the other side equation by subtracting. So I get minus 1/2 x. I always want to put my x first. So I'm just going to subtract this from both sides. And now I get negative 1/2 x plus y equals 1. And it's in slope-intercept form now. So again, I know this might all look kind of strange to you, but you're going to spend more time looking at the Schoology lessons and get better at doing that, is putting a line, or the equation of a line, into 3 different forms. So this equation here represents the same exact line. So that's what I want you to take away. The big thing from this recording today is that this line is represented in 3 different formats. It's the same line. Each of these equations represent the same line. We've just expressed them in 3 different formats. And again, if this doesn't all make sense right now, it will make better sense once you go through all the Schoology lessons this week. This just gave you an overview of what you're going to learn. Ready for the key phrase question? I'm going to put it up. So we talked about finding slope quite a bit in this recording today. And really quick, when you find slope, always keep your slope in a fraction, because remember, slope is telling us rise over run. And if we don't have our slope written as a fraction, we don't know how much to go up or down, or how much to go left or right. So it's very important that when you write slope, you keep it as a fraction. So for your key phrase assignment, I want you to tell me what is the slope of a line that passes through point 1, 4 and another point that has coordinates negative 2, 6. So remember, keep your slope as a fraction. And that's it. Have a great rest of the week, and let me know if you need any help.